welcome back to my channel. Today I want to clarify or just talk briefly about AI agents and what they are actually and effectively. So I see a lot of content online actually talking about AI agents and how you can make money with AI agents quickly, how you can build AI agents. It can be with N8N, with Mac, with Python, with a lot of things. And I'm just wondering I was just wondering myself, what exactly are AI agents and what exactly can we qualify as an AI agent? So the topic seems to be a bit complex, and I see a lot of demo of AI agents online, but I don't see a lot of them in production. So I was just wondering what exactly they are and how exactly we can build them in the production environment. So today we'll be going through one of the most interesting article from Anthropic about the topic, going through what actually AI agents are and how they envision building it in their company. So first, I think the first part of the article is actually defining what AI agents are. It's kind of a complex topic because everyone doesn't agree about the topic, the definition of the term. I think one definition from Google implied that AI agents can be simple algorithms without any LLM, just performing a single task or something. But the one that Anthropic have here is a bit different. So let me read it out for you. Agent can be defined in several ways. Some customers define agents as fully autonomous systems that operate independently over extended period using various tools to accomplish complex tasks. Okay, so here I think we have three main terms. We have independence, we have tools, and we have tasks, which may be really important when it comes to AI agents. So we'll talk about that later. And then others use the term to describe more prescriptive implementation that follow predefined workflows. So I think in this case, you may think about it as an automation workflow. Okay, so you have a set of steps that the AI needs to fulfill to actually perform a specific task. So now at Anthropic, we categorize all these variations as agentic system, but draw an important architectural distinction between workflows and agents. So workflows are systems where LLM and tools were orchestrated through predefined code path, as I mentioned, a bit like automation workflows. And agents, on the other hand, are systems where LLM dynamically direct their own process or tool usage, maintaining control over how they accomplish tasks. So I think this part is pretty clear, like drawing a clear separation between what a workflow can be and what an agent can be. So I think we'll go through it a bit later, giving some example and just giving some real example of how you can actually build a real agent, how you can build a workflow, and which paradigm is actually interesting when we consider these two concepts. So here they go through when and when not to use AI agents. So normally, as in any computer science related topic, you use AI agents only when you need to use AI agents. So in some cases, you don't really need to, and that's what they're saying here. So don't complexify things into integrating agents everywhere because it's cool or something. So using agents involve a lot of things, a lot of iterations. To have a stable solution, it takes a lot of time. If you don't have to deal with that, if you have a better solution, just like a simple algorithm that can solve your issue, or just a simple LLM based solution, or a simple RAG that can solve the problem that you have, it's far more better to go with it than deal with all the hustle of dealing with AI agents and the complexity around it. So here we'll see a bit of when and how to use frameworks. So this is a way for them to tell us that the AI agents is not necessarily coded with Python. You can build them with automation tools, of course, but as you will see throughout the article, there's an important component in this flow, according to Anthropic, which is actually an LLM. So, okay, let's just go down. We suggest that developers start using LLM API directly. Many patterns can be implemented with a few lines of code, and if you use framework, ensure you understand the underlying code. So incorrect assumption about what's under the hood are common source of customer errors. So you have many frameworks, and each framework have a different paradigm and a different way of handling or envisioning what an AI agent is. Yeah, I will actually do a video going through all these frameworks and what is the underlying architecture somehow or idea. So maybe you can understand that a bit more. But what they're saying here is that if you can do it directly with API, with LLMs, just maybe with SDK, do it that way. Because if you take the complexity of an AI agent framework to build a simple solution, you may end up with more problem than expected. Okay, so now we have here building blocks of workflow and agents. This is actually the most important part of the video. You will see here some examples of workflows and agents and how they behave. So you will have a real world example of what an agent actually is. So here, for example, you have the base or really base. I will not call it an agent, but an augmented LLM. So the augmented LLM is where you have an input, you have the LLM, and you have three key components here. It's like the retrieval part to give more context to the LLM, the tool part to actually, call external tools using maybe function calling, and then the memory part where you can actually keep what the LLM is doing and be able to retrieve that later. And then you have the output scheme. So you will see it on this image here, the query, the response, and the rewrite part. So with that said, I think we have a different paradigm here called prompt chaining. Maybe you already know that it's just packing some prompt one after another. I think I showed in one of the video about retail how you can actually implement that using retail for voice AI agent. So in this case, you will see here that you have an input, and the input goes to the LLM. The first LLM is executed, and the output is fed to a gate. So the gate will be something that will help you go to the next phase, like decide if the output is good enough to fail or to go to the next phase. And then in this case, it goes to the next LLM, and the next LLM can call the next LLM, and you get the output. So you will see that this system is quite simple to implement. You can do it directly with the SDK. It's just like, let me just give you a simple real world example. So let's see, for example, you want to build an AI agent that can write simple poems, for example, okay? And you want this poem to be good enough. And in that case, you will have different steps. You have the first step in the first LLM that will actually write the poem for you, okay? You have the gate, and then you have the second one that will review and rewrite, like correct mistakes, like let's say grammatical errors or something like that. And the third one that will just read the structure and add rhythms to it, like, it needs to end with the same sound, something like that. And then you have the output. So you can just do that directly with prompt chaining. You don't even need a complex framework to build something like that. You need a basic knowledge of what LLMs are, the understanding of your use case, and a clear process of how to solve your problem. So when to use this workflow? This workflow is ideal for a situation where the task can be easily and cleanly decomposed into fixed subtasks. And to be honest with you, this kind of, as I said before, this kind of use case, you need to find the easiest way to build it. Okay, you can do it with automation tools. You can do it with a simple OpenAI SDK or Anthropic SDK, or you don't need a complex system to build this kind of AI agents here or workflows here. So now the third one is the third workflow is routing. And the routing here is quite interesting. I've built many systems integrating this routing pattern because most of the use case that you have may involve having special LLMs agents that can handle one task and do it pretty well, right? So in this case, what you can build is a system where you have the input and one, quad or router that will actually decide where your input will go. So it will be like, okay, you want, for example, an AI. You have, let's suppose in this system, a regular example would be you have a system where you have a generalist. You have maybe, let's say, a company wants a tool that may help them manage their marketing, manage their internal documents, learn, or things like that. And you may want a router on top of that to be able to direct the user to the user inputs to the right LLM that's actually fine-tuned and built to handle that case specifically. It can also be just a moderation, so you can have different system, let's say on a moderation, but you find the way to actually separate that into different cases. So maybe you have some community that have different kind of content, and you fine-tune one LLM for that specific kind of content for this community, and you do the second one and the third one, and you have a router that will decide where to send the request based on some specific parameter that you may have, and the output comes from the LLM that's actually handling the request. So yeah, this is a kind of an overview of what workflow, the routing workflow can look like. Yes, and the next one is parallelization. Okay. So this one, as you can see on the image as well, is quite interesting, and I think it's just, I can just give you right away one real example of this so you can see exactly how it looks like. So let's suppose you're writing a blog post, okay, and you want to write it in 3 different sections. You want an AI, one AI can do all that, but you want to fine tune it so that the first AI just write the introduction and the hook, for example. Let's say it's an article about like a structure, pretty structured article that you can write. You have the hook and the introduction that one LLM can handle. You have the component, the core main of the, you know, the story that one other LLM can handle, and the conclusion that one other LLM can handle. So you get the input, maybe the topic, and you pass it to these 3 LLMs. You have the introduction written by one LLM, the main topic written by the second one, and the third written by the last one, and you have the aggregator that will merge all the content and make it coherent and then give you the output. So this is one possible way of seeing this kind of workflow, agent workflow here. Okay, so when to use this? It's effective. This is effective when the divided subtask can be parallelized for speed, or when multiple perspectives or attempts are needed for higher confidence result. For complex tasks with multiple consideration, LLM generally perform better when each consideration is handled by a separate LLM core, allowing focused attention on each specific aspect. So I think this is clear enough. You can see here a bit more, you have more information about it. And by the way, I'll put the link in the description, so you can go through it and read it yourself and maybe understand it better. Yeah, so the other one here is the Orchestrator-worker. I think I'll just quickly go through it. Here you have one LLM that's like the teacher that will orchestrate and be, okay, you will do this, you will do this, and then you have a synthesizer at the end. It pretty much looks like the routing one, but the problem here, or not the problem, but the difference here is that the orchestrator in the process is not just routing it, but it's actually understanding the topic and breaking it down and giving it to people. It's like, as I mentioned, the teacher, right? The teacher or manager in this case. So the manager will get a task, break it down in different topics and give it to different people. So let's say you have a coding exercise, look at this orchestrator as your manager. So he will get the coding task, breaking down into small specific topics and feed it to different LLMs so they can solve it. And then at the end you have a synthesizer. Yeah, so now you have the Evaluator-optimizer. This is a quite useful pattern. Most of the time you implement this with frameworks, but you can also do it with simple LLMs, SDK. And in this case, it's quite sensible, mainly because you need to clearly define when you stop. Otherwise, you will burn a lot of money. You need to clearly put some guardrails and some conditions, because this is like, okay, let me just explain it to you quickly. So you have here an input, and you have a generator and an evaluator. It's just like the coder and the tester. Okay, maybe let's say you have a coding task, and you have one coder that will be just, you know, writing the code, and the tester that will write the test and make sure that the code that the coder wrote fulfill all the tests. So what's happening here is that you write the code, send it to the tester will test. If everything passed, it's good. So it's accepted and it's out. Otherwise, it feed it back with the feedback, and the coder will write it and will write it. So this is quite good when you want a really, really good solution at the end, and where you don't have to deal with, you know, spending a lot of money, because in this case, the AI will we will work in this kind of cycle way until they find an arrangement or until your stop condition is reached, which may be pretty expensive in terms of token, of course. Yeah, but this is one paradigm as well. It can also be a simple content writing system where you have the writer and the redactor and the proofreader, something like that. And then in this system, you have the LLM writing and the evaluator evaluating and saying, okay, the contents are good enough. You can write it again. This is the feedback. This is how you can improve. And in this kind of system, you have a better output at the end. Yes. So now they're talking about agents, and you will see a clear difference here. Is that you have a bit more, the agents are a bit more independent, right? So here, for example, you will see the human giving some instruction to the LLM, and the LLM actually have a stop condition, and it has a kind of connection to the environment. So the environment here is not clearly an LLM, but it can be a set of tools, a set of things that the LLM can use to solve the task. So it's like you can prompt bold.new to code a landing page for you. I think for now, based on the open source code, this is not the best example because they're just using a single prompt. So let's say you have a system like Cursor, for example, and they have an internal system to build, to actually use different tools, use maybe a container to test the app, use whatever they have in your environment to solve your task, and then give you back the result. So, and here you can this agent can be used for open-ended problem where it's difficult or impossible to predict the required number of steps, or where you can hard code a fixed path. Okay, if you ask to an LLM to build an app, you cannot hard code this process. Now, if you want a good app at the end, of course, you cannot hard code this process. So you need to give freedom to the AI to actually choose the tool, choose the steps, iterate over it, and until you get maybe a good solution, and then give you back the result. Okay, you can see here some example: a coding agent, okay, that resolved the SWA bench task, a computer use reference implementation. So these are some good examples here. And then you have a high-level flow of a coding agent. So here we have combining and customizing this pattern. So as you can see, these are pretty interesting way of using and handling AI agents. You can make them communicate, of course. You can make workflow communicate with an autonomous agent. So let's say, for example, you want to write a website, you want to create a website, and this website you need a blog post. You can just make the AI agent creating the website to call the workflow creating the blog post and give it back the result, so you can feed it to the website and everything. So I think this was quite like a really interesting article going through what AI agents are, so you can understand it with real world examples without having to watch all the videos on YouTube. And I hope you understood a bit more what AI agents are and how you can implement them, what's the difference between workflow and an agent. And yeah, thank you for watching, and see you in the next one.